Let's finish up with this quiz review worksheet for 7.2 A, B, and C. For number 2, this is going to be dealing with volume of cross-section, of known cross-section. And this problem is actually taken from one of the homework problems. Find the volume of the solid if the base is bounded by the circle x squared plus y squared is equal to 4. And for the first part, we're going to create rectangles of height 4, and the cross-section is going to be perpendicular to the x-axis. So I drew the circle, x squared plus y squared is equal to 4, center at 0, 0, and radius of 2. And we are drawing bases that's perpendicular to the x-axis. So x-axis is horizontal. Perpendicular means we're going to be making it vertical. So we're drawing a vertical base. We're going to have to go through top minus bottom. The top of the function, everything has to be in terms of x, so we solve for y. So the top graph is y equals root 4 minus x squared. The bottom graph is negative root 4 minus x squared. And so the top of this base is touching the graph root 4 minus x squared. The bottom of the base is on the graph negative root 4 minus x squared. So we do top graph minus the bottom graph. The two negatives cancel out, so our base is now represented by 2 root 4 minus x squared. And we're going to adapt this into the area of a rectangle. So I'm going to draw a rectangle here. The base is the 2 root 4 minus x squared. But they're telling us that the height is 4, so I'm going to just draw a vertical to represent the 4. Now the area of a rectangle is simply base times height, so I'm going to plug that in our formula. Base times height, dx, right? Area of our known cross-section, which is the rectangle, dx represents the width, and our bounds are from -2 to 2, because those are the x values that we're dealing with, right? You can tell by looking at the graph. You can also set the root 4 minus x squared equal to y equals 0, and if you do that, you can solve for x. You'll get -2 and 2 as well. So -2 to 2, we can combine this to be 8 root 4 minus x squared, and we plug this in our calculator. We're going to get 50.266 cubic units. Okay, part B, we're still dealing with the same shaded region, but now our cross-section will be equilateral triangles, but the cross-section now is going to be parallel to the x-axis. So here's the x-axis, parallel, going the same direction. So now we're going to do right minus left. Okay, if we do right minus left, that means everything has to be in terms of y, so I'm going to go back to our equation. We're going to solve for x. X is equal to plus or minus root 4 minus y squared. So now this portion of the graph is represented by the positive root 4 minus x squared. This portion is now represented by the negative root 4 minus x squared. So we do right minus left, right of the base minus the left. The right endpoint of this base is on the root 4 minus y squared. The left endpoint of the base is on the negative root 4 minus x squared. So right minus left, the two negatives cancel out. So now our base length is 2 root 4 minus y squared. Okay. Our formula for equilateral triangle is root 3 over 4 base squared. So we're simply going to replace this with the base that we found from our diagram. So we plug this in. I can pull the root 3 over 4 out as a coefficient. So we go from -2 to 2. I'm going to plug this in the calculator, which will result in 128 over 3. Multiply by root 3 over 4, and I combine this to be the exact value of 32 over 3 root 3 cubic units. Okay, part C. Now we have semicircles, and this will be a cross-section that is perpendicular to the y-axis. So we have the base, and the base is going to be the exact same as part B, since we've already created we've already found the base, right minus left, root 4 minus y squared minus negative root 4 minus y squared, which is 2 root 4 minus y squared. But now this base will represent the diameter of our semicircle. So we just plug the base in for the diameter, and we can then plug in into our volume formula. Again, the bounds will be same as from part B, from -2 to 2. These are the y values that we're using. We plug this in our calculator. We're going to get 128/3 as well. Times pi over 8, we get 16/3 pi cubic units. Part D, isosceles right triangles whose hypotenuse lie on the base of the solid, and the cross section is now parallel to the y-axis. Okay, and our y-axis is vertical, parallel. Okay, so there's also going to be vertical. So top minus bottom. We've already done top minus bottom from part A. So root 4 minus x squared. That's the top curve. The bottom curve is negative root 4 minus x squared. So we subtract those. Two negatives cancel out. So now our base is 2 root 4 minus x squared. Now this base is now represented by the hypotenuse. So we just plug into our formula for hypotenuse, which is 1/4 hypotenuse squared. And we're going to get, we can pull the 1/4 out as a coefficient. Bounds are from -2 to 2. 2 root 4 minus x squared, quantity squared. Again, this will produce 128/3. And then multiply by the coefficient 1/4. We're going to get 32/3 cubic units as our volume.